In this video, we're going to determine a delta for a given or arbitrary epsilon given a function. They say what values of delta are an appropriate choice when proving the following limit. They give us a quadratic, and they say as the limit of x approaches -6, you're getting 6 for your limit. So we can write some things out here that we know. We know that our a value is going to be -6. We know that the function is the quadratic x squared plus 4x minus 6. And we know the L value is 6. Let's write down what the definition for this delta epsilon definition for limit says. So we have the limit as x approaches a of f of x is equal to L if for all epsilon greater than 0, or for any epsilon greater than 0, there exists a delta greater than 0 such that if 0 is less than absolute value x minus a less than delta, it implies that the absolute value of f of x minus L is less than epsilon. So this is the definition, and basically this is talking about the closeness that we are to our x value, our limiting value, which is x as x approaches -6. So this area is talking about basically the tolerance on delta. This is talking about the closeness to our limit, and epsilon would be the tolerance for basically the y value, or how close we are to the limit. And we want to basically restrict epsilon to a certain amount, and then find the delta that fits that piece. So let's start filling some stuff in. We can say that 0 is less than absolute value of x minus -6 less than delta. And then I'm going to add in that this is actually less than. They tell us here you should assume that 0 is less than delta, which is less than 12. So we're going to assume that that means that if this piece, if it's less than delta, then it would also be less than 12. So we end up with 0 less than absolute value of x plus 6, which is less than delta, which is less than 12. Okay, we're going to use this knowledge here in just a little bit. For this piece on the right, we usually like to start with the epsilon, so I just kind of plugged in what we knew there, and now I'm going to plug in what we know here, and we're going to say that this is the absolute value of x squared plus 4x minus 6 minus the limit, which would be 6, and that is supposed to be less than epsilon. So we're going to kind of work down the page here on the right and figure out what epsilon value that we need for this function minus the limit, and then we're going to basically say that delta has to be that limiting value. So we're going to combine this together. That'd be absolute value of x squared plus 4x minus 12 less than epsilon. We're going to factor here, and that will be x plus 6, x minus 2. Less than epsilon. And there's this, basically this is a factor that you should know. If you have the absolute value of a times b, you can write that as the absolute value of a times the absolute value of b. So we're going to do that here. We're going to say the absolute value of x plus 6 times the absolute value of x minus 2 is less than epsilon. Now this is where it gets kind of funky. Because delta is less than 12, we're basically going to say that x plus 6 has to be less than 12. So when we look at this x plus 6 area, we can write this as x plus 6 absolute value is less than 12, which would mean that -12 is less than x plus 6, which is less than 12 when you get rid of the absolute value sign. Now we're trying to work on this x minus 2 piece, because that's the piece that we're really trying to substitute for, because we we know that the absolute value of x plus 6 is less than delta. So this is the piece we kind of want to keep in the equation. Well, to get x minus 2 here, I'm going to subtract 8 from each piece. And when I subtract 8, I get negative 20 less than x less than 4. Now, oh, I forgot, that's minus 2. Now, when I take the absolute value of this, what happens is I take the absolute value of each piece. So absolute value of negative 20, the sign's going to flip. Absolute value of x minus 2, sign flips. Absolute value of 4. So I end up with 20 greater than absolute value x minus 2, which is greater than 4. Well, this is the maximum value that x minus 2 could be. And we know that we can't equal that value there. So if we use, so x minus 2 can't be this value because it's got to be less than 20. So because this times this is less than epsilon, we can plug in 20 there for this piece here, and we'll still be less than epsilon. So we're going to plug in 20 and have absolute value of x plus 6 times 20 is less than epsilon. And then we can divide by 20. On each side. And we end up with the absolute value of x plus 6 is less than epsilon over 20. So then we can say that our delta piece that we're going to use to prove this limit, we can say that our delta has a minimum of 12 and epsilon over 20 is the maximum for delta. And this is what we would use to finish this proof off. They don't ask us to do that, they just ask us to find the delta, and that would be the delta piece that we would use.